Hi, welcome to CoreJava tutorial. So today in this class we are going to learn what are all the data types available in Java and what is meant by typecasting and what is a default initialization. So we are going to learn these three concepts. So here if you observe, see, these are all the three concepts which we are going to discuss in this class. So what is data types and typecasting and default initialization. So if you observe our previous tutorials, so we used to write a program like class A, and inside this class A let's take one integer variable, so which is a non-static variable. In case if you want to load this non-static variable, then obviously we need to create an object of a class, then with the help of this particular object we can access the non-static members, right? So now, so if you observe this particular variable I, so this I is of type int, right? That means the data type of the variable I is int. So if you take the concept called what are all the data types available in Java, so there are 8 primitive data types available in Java. So, okay, so 8 primitive data types are byte, short, int, okay, byte, short, int, long, float, double, character, and boolean. So these are all the 8 primitive data types available in Java. So here, instead of creating this particular program, let me modify the program like this. So instead of creating a variable here or here inside like this, I will create one variable of type of each and every data type. So here what I will do is I will create like this, okay, I will create the variables of all the data types: byte, short, int, long, float, f equals to 1.2. Here I just appended f. So I will explain you why do we go for appending this f. Okay, so here double d and the character is c and boolean is boolean. So now if we let me save the program, and this program has been saved inside a folder called CoreJava. You can see this here under E drive, so CoreJava. So I have saved this particular program here. So let me go open the command prompt. So here if you compile the program java c space a dot java, see there is no compilation error. If you execute the program, so then obviously the output here is, it is, since it is b, so here it will print 10, it is short 20, again 10, and here it is 30, 40 and 1.2 f and 2.2, and here it is a, and here it will print true, right? So let me execute the program, so you can see this one, right? So the same output we have seen. So if you observe these particular variables which we have created over here, so here the byte is of type b, where we use, when we saved the value 10 inside this byte b, and we have saved the same 10 inside this particular f. So here what is the difference between saving the value 10 inside a variable called b of type byte, and what is the, I mean the same 10 I have saved inside a variable called s, which is of type short. So why do we need to go for using these two data types to save only integers, right? So here where exactly the difference lies between these four data types. So if you see, if you observe this, all these four, so we have used this one to save the integer values, right? Here the difference lies, I mean to say, so the difference is, so the first one is, there are few differences are available. So among those, the first one is, so the way of representation of data, and the second one is the range of this particular data types. Okay, so if you take this byte, we can say only the integers which are having up to some range. Let me say it is 120 or 220 or something like that. So here if you go for this short, and the range will be increased, and here if you go for int, the range will be increased. If you go for long, so the range will be increased. That means when we keep going from byte to long, the range of integers will be increased. And the second point, and the one more point, is the way of representation of data. So if we want to talk about the way of representation of data, then obviously we need to consider the memory occupied by this byte, short, int, long, and float. Okay, now if you come to the point of memory occupied by this byte is 1 byte, and the short occupies 2 bytes in memory, and integer occupies 4 bytes, and long occupies 8 bytes, float occupies 4 bytes, and double is 8, character is 2, and boolean is 2. So 1 byte equals to 8 bits. Here it is 8 bit, right? So it is 8 bits, and here it is 16 bit, and here it is 32 bit. Okay, and the below one is 64 bit. 8 8s are 64, right? 64 bit, and the next one is 4 bit, that means it is 32 bit. 32 bit, and here it is again 64 bit. Yes, it is 64 bit, and here it is again 16 bit, right? Let me come here, it is 16 bit, and here it is again 8 bits. Okay, so here if you see this particular memory locations, and it is 8-bit memory, and the short is 16-bit memory location, and the integer is 32-bit memory location, and long is 64-bit, the float is 32-bit, and double is 64-bit, and character is 16-bit, and byte is boolean is 8-bit. So here, so if you come to this particular program, so here 10, the value 10 we have saved inside a variable called b of type byte. So if you come to this memory locations, so what the byte occupies only 8-bit. So here the value 10 we are representing as 8-bit memory location. So if you come here, the same value 10 which is saved inside a variable called s is of type short, so we are representing that one as a 16-bit memory location. Here the way of representation of data differs from data type to data type. Okay, here the 10 is 8-bit, and here it is 16-bit. Okay, the value 30, here it is how many bits? It is 32 bits. Okay, so the way of representation of data will differs from data type to data type. Okay, so now what I will do is, so this, okay, the first concept is data types. So these are all the primitive data types are available in Java, and the memory occupied by this, I mean what is the memory occupied by the each and every data type in terms of bytes and in terms of bits. Okay, so the next one is typecasting, right? So now what I will do is, I'll come here. Okay, let me have a divider here so that we can clearly differentiate the output in the console. So let me have one divider saying that star. Okay, yes, and the next one is here. What I will do is, I will try to print, let me create one variable of type byte b1 equals to 20. Okay, so now int i1 equals to b1. So if you observe here, I am trying to save the value 20 inside a variable of type byte. Okay, and I am trying to assign this byte to this particular integer. So if you come to the point of the memory locations here, I am trying to convert the 8-bit value to the 32-bit value, right? So here I am trying to assign a smaller location to a bigger location, so that will be acceptable, right? So here, okay, now let me create one more thing. So here I will create int, okay, int i11 equals to 20, then byte, okay, byte b11 equals to i11. So here I am trying to create see here, I am trying to assign the value 20 to the variable i11 of type integer. So now I am trying to assign this particular integer to this particular byte variable. That means here I am trying to assign 32-bit memory location to 8-bit memory location, but that means this is a bigger value, it is a smaller location, so which is not possible. So let me save the program first and compile the program. Yeah, java c.a.java. See, it is throwing the compilation error saying that b1. Okay, so this is different error, b1 is already defined. So let me create, here it is a b2, and let me assign here it is b2. Okay, So first we comment this, we make sure that whatever the code we have written over here, it is executing and compiling fine, right? So let me come here and compile the Java class and execute it. See, it is executing fine, right? So now what I will do is I will uncomment these two lines. So now it should throw a compilation error because we are trying to assign a bigger locations to a smaller locations. So right, so that means we are trying to assign 32-bit value to 8-bit value, right? So here it is not possible in Java. See here, it is throwing compilation error saying that possible loss of precision. Okay, so in case, okay fine, so this is not allowing, right? So the next one I will try to explain is, let me comment this. Okay, so what I will do is int I equals to so a. Okay, so if you see here, so I'm trying to assign the character value to the integer. Okay, so is it allowed? Okay, save the program and compile the program first. Yeah, see, it is saying that the variable I is already defined, so it is a compilation error. Okay, let me create a variable int character 1 IC1. Okay, save the program and come here. See, there will be no compilation error. See, is there any compilation error? No. So here I am trying to assign character to the integer, but which is not acceptable, but here it is not throwing any compilation error. It is saying that it is okay, right? So then what is happening in the background? Okay, so before that, let me create one variable character. Okay, character ci equals to, I will assign some 9. Okay, let me save the program. If you observe this particular line here, I am trying to assign the integer value to this particular character. So here, so will it allow? It's supposed to, I mean it should not allow, right? Okay, you just come here and compile the program. See, there will be no compilation error. Yeah, so what is happening in the background? So if you observe this, there is a something called typecasting. Okay, a typecasting in the sense, it is the process of representing the value of one data type into its equivalent value of another data type. Okay, that means this is one data type and this is another data type. That means we are trying to represent the value of one data type into its equivalent value of another data type, but here it is not allowing. Okay, there are some exemptions in Java. Okay, so here what is the typecasting? A typecasting is the process of converting the value of one data type into its equivalent value of another data type. So let us print what is the value of IC1 here, so that we will come to know, right? So here, if I print this IC1, okay, IC1 equals to IC1, and if I print CI here, okay, CI, let us see what is the output it will give us. Okay, so save the program and come here and compile the program and execute the program. See, IC1 is 97 and CI is space, it is showing. Okay, so let me change this to 19 or whatever it is. Save the program and come here and compile the program. Okay, so there will be no compilation error, and execute the program. See, it is showing some character here. Okay, that means here typecasting takes place. Okay, what is the typecasting? The value of representing the, it is the process of representing the value of one data type into its equivalent value of another data type. So here this is character. So here the ASCII code of this particular character A is 97. That is internally converted, I mean by the JVM, that has been initialized to this particular IC1. That's why we are seeing this particular output over here, 97. So if you consider this 19, this is an ASCII code of this particular symbol. Okay, this one. So that is the reason we are able to see this particular thing over here. But if you come to the point of this, so here it is giving us a compilation error. If I uncomment this, obviously we can see a compilation error saying that so casting is not possible, like, okay, see here, possible loss of precision. Then what do I need to do to avoid this compilation error? So we need to typecast this. Then how can we typecast this, right? So here we are trying to save integer to the byte type of variable, right? So here here we have to mention like this. So within the open and closed brackets, byte byte. So we have to mention the target data type. The target data type in the sense what? The data type to which we are converting to. So here we are converting this integer value to the byte. So we just mention byte over here and save the program and come here and compile the program. So here there is no compilation error. If you execute the program, see, it will execute fine. That means here it is, see, here I am not mentioning anything for typecasting. Here explicitly I am mentioning byte, right? So there are two types of typecastings are available. The first one is implicit typecasting and the second one is explicit typecasting. Okay, implicit typecasting in the sense, it is the process of converting the value of one data type into its equivalent value of another data type without our consent by the JVM automatically is known as internal typecasting. So here external typecasting or implicit typecasting. Okay, so here it is internal typecasting or implicit typecasting. And what is meant by explicit typecasting? Okay, an explicit typecasting is the process of converting the value of one data type into its equivalent value of another data type, okay, with the help of or as per our specifications in the program by the JVM is known as external typecasting. Okay, so an external typecasting is a process of converting the value of one data type into its equivalent value of another data type depending upon our requirements. I can say with depending upon, I mean, the way we have written the code. Okay, so here there are two types of typecastings are available. Okay, so the next concept is default initialization. Okay, so what is a default initialization? So it is initializing a variable in the sense assigning a value to the variable, right? Yes. So here what I will do is I will come to the same program. Okay, otherwise let me create one more program. Let me create a class B. So inside this particular class B, so here public, I will create one main function, public static void main. Here it is string args. Okay, so here inside this particular main function, okay, let me create a main function. Here inside this particular class B, what I will do is I will create all these variables. Okay, I will create all these variables. So here it is byte, short, int. See, I have created all the variables as a non-static variables inside a class. Okay, so let me remove these assigned values. Okay, and here see, I just removed every value which is assigned to the data types. Now what I will do is, if I want to access the non-static variables of a class, then obviously we need to have an object of the class. So let me create an object of the class b equals to new b. Okay, so here let me have the system.out.println statements so that we can access these values, right? So we just come here and paste it over here. So here byte, it is b dot b. That means obviously with the help of this object I can access this particular non-static members. Here it is short is b dot s, and here it is integer b dot I. If you come to the point of long, it is again b dot l, b dot f, and here b dot d, and here character b dot c, and boolean b dot b1. So if you see this, let me save the program first with the name b dot java. Okay, so if you observe this program, so here I have created variables of each and every data type, but I didn't assign any value to these particular variables, but I am trying to print the value of these particular variables with, you know, in this particular main function, right? So here let me compile the program. Let us see whether it will throw any compilation error or not. Java C space a dot java. Okay, so it's supposed to be a .java. Okay, yes, see, there is no compilation error. Now if I try to execute this particular, sorry, it's b.java, not a, b.java. See, there will be no compilation error. See, I just created a program with the name b, and I'm compiled. I compiled this particular program. Is it? So there is no compilation error. Now what I'll do is I will execute the program. See, with the help of Java command. So if you see this, it's a Java space b. Then what will be the output? So let us see the output first. So here it is, byte equal to 0, short equals to 0, int, long, float, double, character, and boolean. So for character we are not able to see anything over here, right? Okay, now see here, do we assign any value for this? No, right? But how all these variables, so how this particular b has been assigned, how this particular s has been assigned with the value 0, how this particular integer variable I has been assigned with the value 0, and how this particular float value has been assigned with the value 0.0, and how this boolean b1 has been assigned with the value false, right? So here there is something called as, whenever the Java compiler or JVM, not Java compiler, so whenever the JVM tries to execute the program, or whenever, so here the JVM, I mean here the default initialization takes place. Okay, so whenever the Java compiler tries to compile this program, the Java compiler will check whether the variable, instance variable, has been assigned with any value or not. In case if the Java compiler feels that it's not been assigned with any value, then obviously depending upon their data types, depending upon the data types of the variables, it will assign the variables with their default values. Okay, so the default value of byte, the default value of byte is 0, and the default value of short is also 0, and the default value of int is 0, and long is 0, and float is 0.0, and double is also 0.0. For this, it is, for character it is a space. Okay, it is a space. Okay, space. Okay, so here it is, for the boolean it is false. Okay, so the default values of each and every data type, so byte, for byte, in short, int, long, it is 0, and float, double has 0.0 as a default value, and character is, there is a space. Okay, one space, and boolean is false. Okay, so now what I will do is, so instead of, see here, since it is the, I mean the Java compiler itself is, or the JVM itself is assigning the value 0.0 to the f. Now what I will do is I will assign 0.0 here. Okay, f equals to 0.0. Now let us see whether it will get compiled or not. Okay, so let me compile the program. So Java C space this, and see, it is showing some compilation error saying that possible loss of precision. Okay, so we have seen this error before also, right? So whenever we use it to, you save the bigger values to the smaller location, we got this error. So this is what the error now also we are getting, right? So here, so what is this particular 0.0? So the moment when we print the value, it is showing us 0.0 as a default value, this particular float variable f. But if we are trying to assign the same value, but it is not accepting here, that means here something is happening in the background, right? So what is that something? So here each and every decimal values, I mean to say non-decimal values. Okay, so each and every non-decimal values can be considered as a 16-bit value by default by JVM. Okay, so here it is, sorry, it is decimal values, right? Yes, so all decimal values will be considered as a 64-bit memory location. Okay, 64-bit memory value. So here, since the memory occupied by this float is 32-bit, and we are trying to save the 64-bit memory value to 32-bit memory location, which is not possible. So to avoid this, we have to go for using typecasting. That means either we have to go for using explicit typecasting. Okay, so here it is float, and if you mention like this, then here you just come here and compile this particular class and execute this class. See here, so there is no compilation error and it got executed fine. That means we have to go for explicit typecasting. So here either you can go like this, or you just simply append the alphabet F, that's it, as a prefix. Okay, so if you append F, so internally it will convert it into the value of type float. Okay, now you come here and compile the class. Okay, javac space b.java and execute the class. See here, so there is no compilation error and there is no runtime error. So that means here the typecasting takes place. Okay, so as we discussed before, so this is an external typecasting. Then what is the default initialization? See here, this is default initialization, right? So that means though we are not assigning the values, by default the JVM itself is assigning the values to these particular variables, right? So then what is the default initialization? A default initialization is the process of assigning the values to the variables depending upon their data types by default by the JVM is known as default initialization. And the default initialization is applicable to non-static variables and static variables of a class. The default initialization is not applicable to the local variables of a function. So here, so these are all the non-static variables. So if you want to create the static variables, let me create one static variable of type let me create float f11, that's it. So here save this particular program and let me have a divider over here, so saying that we are trying to access non-static variables over here. Okay, so star, and so here I will print this particular static variable. Okay, f11, okay, equals to plus f11. Okay, so save the program and come here and compile the program. See, there is no compilation error. Now if I execute the program, I can see 0.0 here. Okay, so now see 0.0, f11 equals to 0.0. That means default initialization is applicable to the static variables of a class. So now let me have one more local variable inside this function. So it is float, okay, f, that's it. I won't assign any value. So now I will try to print the value of this f. Okay, so here it is f and here it is f. So since the default initialization is not applicable to the local variables of a function, then obviously it has to throw the compilation error, right? So now we just try to compile the program. See, it will throw a compilation error saying that variable f might not have been initialized. Okay, that means we have to initialize the local variables. So in case if you don't initialize the variable and if you are trying to access the variable, then obviously this will not be allowed in Java. Okay, so what is the default initialization? It is the process of assigning the variables with their default values depending upon their data types by the JVM is known as default initialization. Okay, default initialization is applicable to non-static variables of a class, static variables of a class, that's it. And default initialization is not applicable to the local variables of a function. Okay, so here see the default initialization of this character is space, right? So here we are not able to see any space. So here it is not, space cannot be visible, right? So if you want to make sure that whether it is printing space or not, let me append something over here. Let me print star star star. Save this and compile the program. You come here and compile the program and execute the program. So here f, right? So what I'll do is I will assign simply 0.0 f to avoid the compilation error. Save here and come here and compile the program. There will be no compilation error and execute the program. If you see this, so here this output character, Okay, so here this is char, and here soon after that there is one colon. So here colon, after that I'm just printing the value of the character, then again I'm printing this particular stars immediately after this particular value of this c, right? That means here there is a space. Okay, so this is, see, you can see the space over here, right? So this is the default value of the character. Okay, so today in this class we have discussed these three concepts. What is data types? The data types are the one using which we can save different data type values into the variables. There are 8 primitive data types are available in Java, that is byte, short, int, long, float, double, character and boolean. So if you come to the point of typecasting, so what is the typecasting? It is the process of representing the value of one data type into the value of another data type, is known as typecasting. There are two types of typecastings are available. The first one is implicit typecasting and explicit typecasting. So implicit typecasting, in a sense, it is the process of converting the value of one data type into its equivalent value of another data type, depending up, it is the process of converting the value of one data type into the value of another, into the equivalent value of another data type without our concern, automatically by the JVM, is known as implicit typecasting. And explicit typecasting, that in the sense, it is the process of converting the value of one data type into its equivalent value of another data type sorry for this. So it is the process of converting the value of one data type into its equivalent value of another data type, depending upon our concerns, depending upon our criteria, is known as explicit typecasting. So if you come to the point of default initialization, a default initialization is the process of assigning the variables with their default values depending upon their data types by the JVM, is known as default initialization. Okay, so going further, we will discuss what is a constructor, and what is a this keyword, and what is a static. If you observe this particular program b.java, there is a variable called static, right? So going further, we'll discuss what is this static and what is this particular open brackets and close brackets. This indicates the constructors, and then this what is a this operator, then inheritance and every concept. Okay, thank you for watching.